Continuing Saxon's Trig, lesson 94, graphs of secants and cosecants, and then tangents and cotangents. So due to some technical difficulties, I lost the first part of the video. I'm not going to repeat it to put it all in one. I'm just going to continue. So we have the graph of cosecant where this curve doesn't really exist. It's just the u's. We have the same thing here with secant. The curve doesn't really exist. We're just interested in the u's. And in the basic pattern, you've got two half of u's is what I was telling you. So in example 1 on page 547, it says write the equation for these trig functions. So this first one has asymptotes at 180 and 360, and it has two full curves. Therefore, it is y equals cosecant of, and at the end of the graph, it was theta. So we'll say cosecant theta here. There's your basic graph. In the second one, asymptotes are at 90 and at 270. We've got half curves and a full curve, which means it is the secant of, and again, at the end, it gives you theta. Now, example 2 says write the equations of these trig functions. So I again look to see I have asymptotes at 180 and 360. And I have two full curves, so I know that this one is falling to be cosecant of, at the end of the graph, theta. But just like with sine and cosine, if you have a shift with the height or the center line, you need to write them in front. So it is still starting at 0, but the high point doesn't go up to 1, it goes to 0.5. So my center line was still 0. My 0.5 I'm going to write as a half, just preference, and it will be y equals, so the 0 thing doesn't matter. And I assume positive. Oh, sorry, I'm catching that they gave you some other piece of information in example 1. Let me come back to that. So basically, this would be what I would be writing. Y equals a half or 0.5 cosecant of theta for that one. For the second part, it has asymptotes at 90 and at 270, a full curve and two partial curves. It has a center line of 10, so we're going to call it y equals 10 plus, and then its height goes from 10 to 10.5. So again, I'm going to write that as a half, and then it is your secant theta. Now, I said back in example 1, I realized that they did something else. I'm giving it to you in its basic format. They're saying that it could be the same thing as a secant shifted except for the asymptotes, because that would change the asymptotes. And they're saying you could also write it as cosecant, shifting it by 90 degrees. Now, doing that will also change the asymptote, so I don't agree. Now, you can have shifts with these, and it will also shift the asymptote. So changing this to starting at, well, if they said plus 90, at negative 90, you are going to shift your asymptotes over a section because your start has shifted over a section. So I do agree with that. But for when they give you the basic picture, you're going to stick to the basics and not assume the oddities. All right, now let's talk about tangent and cotangent for part B. All right. For tangent, you need to basically memorize your asymptotes. I need at least 4 sections. So the first asymptote for tangent of theta is at 90 degrees. And then, oh, excuse me, sorry. Oh, to 70 degrees here and here. All right, so then just to, well, I'll just do the half a curve. All right, so because tangent is not based on a curve of sine or cosine, it's a unique picture. And so I also have to memorize that it goes through 0, 0, and for tangent, it does a climbing motion. And since I don't have the other asymptote, I'm just going to finish the climb here this way. Now for this one, because I have both boundaries and I know that it's going to go through the center in between here, I'm going to climb it. Now you can see what the whole thing looks like. And then this one would actually only have this part up to, but you get the idea that it continues on and on and on. So you get full curves everywhere you're going. But the basics are asymptotes at 90 and 270. And because I want them on the same page so you can compare, I'm going to try to cram cotangent theta into the picture here. So my memorized asymptotes are at 180, so just the opposite, and at 360. Again, starting at those center places, but instead of climbing, cotangent falls. So it actually gets, should be more curved. That's a little bit better. Okay, so you get the idea that it's curving, but it's falling, and tangent is actually climbing. Now, example 3 says, sketch the graph of y equals -2 tangent of theta. So this is giving me a change in my height, but my tangent is the same. So as I have been memorizing, or starting to memorize anyway for you guys, starting at the middle, 2, 3, 4, my memorized asymptotes were at 90 and 270. And you don't have to label the asymptotes. You could choose to label the other two, but at least label 2 somethings. We know that tangent does a fall, and so this one is continuing down here, but I haven't dealt with this -2. So before, I didn't really stress over here that this curvature should be hitting at about your high point and your low point. So what you're going to do is adjust that, goodness, from your 1 to a 2 in both directions, 2 and -2. So now I want my curve to hit at approximately -2. So I want it more like so. So I'm going to just be a little bit more precise. And low point curvature about here, high point curvature at about here. So something along that line is what that's going to look like. And then I could do the other half in that piece, but I believe that you kind of get the idea. All right. Oh, I didn't say one thing. It's good. That's why I was double checking. Tangent normally climbs. Why did I make this one fall? Because it was negative. I fixed the 2's, but the negative flips the direction. So if you have a negative with your cotangent, instead of falling, it will climb. So the asymptotes are extremely important to help you figure out which it is, because you could have the same looking curvature for both tangent and cotangent. But unless you're seeing shifts and unless the problem says you have a shift, assume the normal and negative has flipped the direction of the curve.